another episode, Vintage Electronics. Here's a standard in the 50s, your standard 5-tube table radio. This is a Bendix.
This is a interesting radio because, for one thing, it was actually 1946 model radio, even though these same radios were very popular all the way well up into the 50s. So in fact, to the point where transistor radios came in and supplanted them. What's interesting about this radio is what you call the Catalyn radio, C-A-T-A-L-Y-N, which is the type of material that the case is made out of. It's a form of plastic. The value of this radio is extremely out of proportion to what it should be, and the reason was the Bendix Corporation that made this radio was already in the electronics business for military purposes during World War II. They were making radios for airplanes during World War II, along with some other types of electronic equipment, guidance systems and other things. When the war ended, they were in a perfect position to go back quickly into manufacturing radios for the home market, for civilian market. So there was a lot of Bendix radios produced right in that era, and a lot of people who had been limping along on old radios because you couldn't buy radios during World War II, new radios anyway. So people ran out and got themselves a new radio as quickly as they could. So there was quite a few of these things around. And we believe that the reason the value of this is so high is because when the baby boom generation happened right at the end of World War II, a lot of people were looking for radios for their nurseries or music for the kids or whatever, or home radios for entertainment for the family for that matter. And this is probably the radio that they were able to get. It is the easiest of all the radios on the market to get your hands on one of them. And so there's a tremendous nostalgia value for these because a lot of people had them. It was either their radio or their grandma's radio or somebody's radio. It was involved in their childhood, and so the value of these things is just absolutely crazy. It's just like a Walton's radio. There's a Zenith radio that is a Walton's that the Waltons used on a TV show, and that particular model of radio is going for about 20 times what any other Zenith radio is going for. It's simply because it was the Walton's TV radio. The interesting thing about it, though, is that Earl Hamner, who was the person that the Walton series was based on, he was the writer of the series. It was based on his own childhood. Hamner actually had an Atwater Kent radio in his home. We saw it. We went to visit his house, and it was not a Zenith radio. So,
and of course, we're pre-baby boomers. We were old enough to be witness to.
I came in right on the front end of it. You a little bit before me. I was born right at the end of the war, so we know what they're talking about. Anyway, we're going to go ahead and we're going to open up this old Bendix today and take a look and see what needs to be done to it to get it playing again. The first thing we want to do is on any of these radios is to remove the knobs. You don't want to ever try to take it out of the case with the knobs on because you can crack the knobs.
And sometimes if a knob is difficult, you can take a rag and fold it a couple times and work it behind the knob and pull it off that way.
That's true.
So you kind of spread force evenly all around the knob.
Yeah, you have to be very careful not to crack these cases because any strain you put on them, they will crack. And of course, the value of the radio, aside from nostalgia, is in the case, the Catalyn cases.
Yeah, these are sort of Bakelite. They're fragile. If you bump them just right, they'll crack.
There's a whole segment of collectors that collect old Catalyn radios, so it's a specialty field in the collection market. Some people that's all they collect, and there were quite a few types of these made both before and after the war. Okay, we now have the screws out, and we're ready to take the chassis out. On the back of the chassis, this coil here is actually the radio's antenna.
Convenient screw here for adding an external antenna to it if you want to really bring in long distance stations.
Okay. All right, we got the radio out of the case. Let's go ahead and set the case aside so we don't take a chance on knocking it off the bench. As you can see, this radio has a number of features that we want to look at. For one thing, it has no power transformer. It's what we call a 5-tube hot chassis radio. Famous 5 or the All-American 5 is what you generally hear these referred to. It has a 35Z5 rectifier, a 50L6 audio output tube, and then a 12SQ7 audio tube. It's a first audio stage. It has a 6SA7 converter and a 6SK7IF amplifier.
And if you're adding all those numbers up, it comes up to 117 volts.
That's right. The filaments are all tied in series and directly across the 117 volt line. It has a 6-volt pilot lamp in it here for dial lamp, and there's a provision for this on the filament winding of the 35Z5 rectifier tube. The tube actually drops voltage to light this lamp, so that's built into the design of the tube.
In a more expensive radio with a transformer, there would actually be a 6-volt tap on the transformer,
right,
for the light and for 6-volt.
Yeah, they also, some of them use 12-volt filaments, but this is typical of what you found in the late 1930s on up into the 50s. And the only thing that ever changed on this type of design was that these large octal tubes were replaced with 7-pin miniature tubes. There's an exact replacement for these tubes in the 7-pin miniature variety. 35Z5 would be a 35W4, 50L6 would be a 50C5, but just a different base on the tube, but basically the tube was doing the same thing.
But there was a tremendous savings in cost and weight by manufacturing this way, not having a power transformer.
This is true, but the trade-off on this was that it also produced a dangerous radio, because the chassis on this radio, if you put the plug in backwards, if you notice the plug on this, both prongs on the plug are the same size, unlike prongs on things that we have today that have 2-prong plugs on them like this. One prong is larger than the other, so that when you go to plug it in the outlet, you notice on an outlet we have one large prong and one prong small. You can't put the plug in backwards. And on a radio like this, you can put this plug into this outlet in either direction, and if you put it the wrong direction, the positive lead ends up connected to the chassis. So if you touch the chassis and you touch ground at the same time, or another radio or any piece of equipment that's at a different voltage potential, you're going to take a 110 volt, 117 volt shock.
And that's another reason for this plastic case, because it's pretty much all encompassing.
Right.
This and the knobs on it. So the only way you could get a shock off of this was from the screws on the bottom, which screwed right into the chassis.
That's right.
Or if you touched something on the back.
Yeah, I mean, you had to go looking for it to get a shock.
Yeah.
Okay, so the components on this radio, and if any of you looked at our earlier show that we did on the Howard restoration, we basically have the same parts here as far as IF transformers and a tuning capacitor, and this little transformer here is the output transformer that connects this audio output tube to the speaker. This is a super heterodyne radio, so and I'll briefly explain this because we did it. If you're interested in more information on this, you can go to our first show that was on the Howard radio, and it explains more about how a superhet works. But basically what happens on the superhet radio, the antenna signal goes into the converter tube. The converter tube mixes it with a signal from a local oscillator, which produces a single frequency that contains all the information. That single frequency is 455 kilohertz on most superhet radios. There are exceptions to that, but the typical 5-tube radio, that's what they use, 455 kilohertz IF. The signal goes through the first IF transformer when it comes off of this converter tube, and it's amplified by what we call the IF amplifier. IF amplifier goes through the second IF transformer, and then it's converted out to audio. So this tube is an amplifier, but by having one single frequency that it needs to amplify, being 455 kilohertz, we can get much more efficient amplification out of it than if we were trying to amplify all of the RF that was coming into this radio. Particularly, this was important in radios like this that had short wave or other bands on them too, because all right, so had a short break there while we changed video reels. We're back to the Bendix radio. We're looking under the chassis right now. And there's a couple of things under here that we're going to be concerned about. This radio, when it was given to me 40 years ago, I changed the electrolytic capacitor in it, because the capacitor that was in it at the time was completely bad. So it has a 40-year-old new electrolytic in it. We're going to go ahead and replace that electrolytic. After 40 years, it's time to put another one. We go to a place called Antique Radio Supply, or it's also known as Tubes R Us, in Tempe, Arizona. You can see them on the internet. In fact, if you go to our Museum of Yesterday website and look at the link page, we have a link to that company on there. They still sell and manufacture and sell capacitors for antique radios, a lot of them. And this is the replacement capacitor that we're going to put in place of this one. It's a 33 microfarad, 47 microfarad capacitor. What it does, this capacitor acts as a pi network, and it's tuned by virtue of the value of the capacitor, two capacitors in here, to filter 60 cycle hum. This radio, the rectifier in it, when it rectifies DC, it produces 60 cycle pulsating DC, which then has to be filtered out into pure DC so that you don't hear hum in the audio. A radio with a rectifier tube, if it has a full wave rectifier, like a transformer set, will produce 120 cycle hum. So the filter capacitors in those radios where there's a full wave rectifier has to be different values in this so that it's tuned to filter out 120 cycle ripple rather than 60 cycle ripple. So that's something to remember when you're changing. If you don't know the value of the capacitor and you have to estimate and replace it, you can actually run calculations on this thing using a formula 1/2 pi FC, which will give you the value of the capacitor that you need to resonate at the frequency that you're trying to filter. It's a narrow filtering. The other thing, this radio doesn't have a whole lot of capacitors in it. This is a paper capacitor here that we'd be concerned about. Now
this one looks pretty new.
Yeah, this is a mica capacitor right here. It's pretty new, and generally these don't go bad. They they last a lot longer than capacitors that have electrolyte in them like these do.
And these resistors, in my experience, they typically don't necessarily go bad, but the old ones, the values can change.
Yeah, what you really need to look at on resistors is that if the resistor is in a position where it's processing any amount of current and it tends to get hot, that can change the values. These are nothing but sticks of carbon, and the carbon acts as a resistor. And so if you heat it up, the molecular structure changes, and it can crack and do other things too that'll cause it to change value. If the thing is not discolored or anything, I mean, like this one here, it's obviously not discolored. The green, we have a green and a brown band, which means this is a 150 ohm resistor. The colors are perfectly visible and clear. So, excuse me, we're going to assume that this resistor is in good shape.
Here's something else to look at. The tuning capacitor is actually mounted on some isolators, and oftentimes this rubber will go bad over the years.
Right.
You might actually short out to the chassis, which would kill the signal.
Kill the incoming signal, right?
So you check on that, and you can actually replace these bumpers if you need to.
All right. So if we want to check and see if this radio is capable of playing, I'm not going to go ahead and change this capacitor on the film because it's going to take too long. We'll do that as soon as we finish the video. But I'm going to go ahead and I'm going to change this capacitor and this capacitor, assuming that that's the two that are going to give us trouble. We possibly want to look at this one also because this is another wax capacitor. It's the type that's not. It has quite a bit longer life than this one would normally have, but it's. I probably change those three capacitors and let it go with that, and the radio should play. Now, I wanted to show you all something that we came up with after the last video that we did on the Howard radio. This is a handy little device, and I can't take credit for discovering this because I actually got this off of another video on YouTube where somebody was restoring a radio. But this is a person on the other video had. He was checking his transformers on his radio before he put high voltage on them, just to make sure that they weren't shorted or anything. And the way he did that was he used this variable voltage transformer and slowly brought the voltage up and looked to see how much current the radio was drawing. Because if the transformer or anything in the power supply was shorted, he'd be drawing excess current before he actually got to the point where the radio would would normally play, where it would normally function like it's supposed to. So this is a little device that has a voltmeter and a ammeter. The ammeter goes up to 5 amps, which is plenty enough current for just about any piece of electronic equipment in the home entertainment field, radios, televisions, or anything like that. Even a color television generally draws, if it was a tube set, drew less than 5 amps when it was running. And then you have 150 volt AC scale here. So what you do, you put this on in between your variable transformer and your radio. There's a plug in the side here, you can plug the radio in. I made this up with some meters that we actually had here in the museum as display items. These were antique meters that we had on display, and so I just put them in this box. And we can use this to check a radio when we have it on the bench to make sure it's not going to draw excessive current before we actually ramp the voltage up on it. The other thing that you have to be really careful of on this radio is, because of it being a hot chassis radio, you don't want to have it on the service bench plugged directly into the wall, into the line voltage. What we use is an isolation transformer. This is a really fancy isolation transformer, but you need some kind of a transformer that isolates line voltage from the radio. And what this is a winding that connects to the wall socket, and another winding in the transformer that brings 110 volts off the transformer. But are we still recording?
Yeah.
Brings 110 volts off the transformer for the radio, so that the radio is not connected to the line. It's only connected through the transformer, and therefore the chassis is not at potential where you could get electrocuted by touching something that's earth grounded in the building.
Let me set up zoomed in on that.
Okay. If you want to build one of these, you don't have to go out and buy an expensive isolation transformer. The transformer that's in this is an old control transformer out of an air conditioner, a commercial air conditioner. It was designed to have a 220 volt air conditioner to produce 110 volts for the control voltage in the air conditioner. So it had a tap on it where you could make the transformer do either 110 in, 110 out, or 220 in and 110 out. We just wired it up as 110 in, 110 out, and so it'll work as a radio isolation transformer for about a third of the price of what the same potential a transformer would cost you if you went out and bought a real isolation transformer.
I wanted to point out something under the chassis here. These lead lengths are pretty long on all the components, the resistors and everything. Of course, these were assembled by probably tables of mostly women doing the soldering and everything.
People who had been building bombs before.
Yeah, but typically you try to have a little shorter lead lengths on these, because the more lead you have sticking out in the air, the more chance of picking up hum. Of course, and it's all covered by this chassis which shields it, but the bottom, the plastic of the chassis or the cabinet on the bottom isn't going to shield. So anyway, you want to try to minimize the lead lengths in a radio if you're soldering it up.
This is true. It's not quite as critical in the audio section or the power supply, but when you get in the RF section, what Ray's saying is absolutely critical. You can, just a little bit too much lead length, and you can actually change the frequency of something. Acts as a coil rather than a lead.
And of course, you can retune the radio with these coils on the top, but still, you want to keep your lead lengths short as possible.
Okay, what I'm going to do is I'm going to temporarily put the knobs back on the radio just as a safety precaution. Even though we're on an isolation transformer and there's no way we should worry about getting electrocuted, I always like to not touch these chassis any more than I have to. So I'm putting the knobs back on.
Chicken.
Yeah, call me chicken. Better safe than sorry. What we have here is the isolation transformer connected to the output of the variac. So I have 110 volts from the wall coming into the variac. It's going into the isolation transformer, so I can vary the voltage coming in and out of the isolation transformer. Our radio is plugged into the isolation transformer, so technically it's not connected to the 110 volt line other than through that transformer. I have the radio turned on and the volume control set about 2/3 of the way up, and I'm going to go ahead and start bringing, what I'm going to do is bring the voltage up very slowly on this thing to make sure that we don't see anything doing anything it's not supposed to do. So
Since it's an old radio, will it bring in old programs?
Oh, it can if we have a transmitter to transmit it. That'll be another show we have to do. We actually designed a transmitter that you can use, a low-power transmitter to play your old radio recordings.
Will it get Arthur Godfrey?
If you got Arthur Godfrey tapes, it will. Okay, so I'm turning the power supply on now, and I'm going to start bringing the voltage up very slowly.
Point out the meter.
Yeah, we have a meter here. I also have a meter on here, but I'm going by this meter. Right now we're putting about 50 volts to the radio. And we want to just watch that we don't have anything flashing and arcing.
You see any filament glow yet?
You probably won't at 50 volts. What you're looking for right now is things sparking and spuds. And
yeah. Smoke?
Smoke, yeah, definitely no smoke. Okay, looks like we're safe there. I'm going to go ahead and bring it up another couple of notches. And we ought to start soon. If everything's working, we ought to start hearing some hum out of the speaker. We're up to 75.
There's the pilot light.
Pilot light's coming on. And since the pilot light's lighting, that means our rectifier is working. And apparently our power supply is not shorted out. So we give it a few minutes, a few seconds anyway. At 70, we're up to about 85 volts right now. I'm only going to take it to just over 100 volts, even though the radio normally runs at 120 volts. I'm going to keep it on under 110 volts just to be safe, since we got that questionable capacitor still in there. Okay, we're up to 110 volts right now. 100 volts right now. Power lights at full brilliance.
Yeah, it's really bright.
Let's see if we have anything going on here. Okay, we're not getting any signal that I can hear. I have a little hum in the speaker. You take it up just a tiny bit more to see, it might be in the threshold. I don't want to blow the pilot light out. Alright, now we're up to 110 volts on it. We ought to start, if the radio's working, we ought to start hearing the signal.
I'll do a buzz test on the volume control.
And that's what we're going to do next. Alright, so we don't have any audio, so our radios, I didn't put an antenna on it. I wonder if it's going to make a difference. No.
John's using his finger as the antenna.
Okay, so we don't have any audio. We have a non-functioning radio here. We're going to have to go into it and see what's going on. So we're going to go ahead and shut the video down and do a couple of checks on the radio, and we'll be back with you as soon as we figure out what's wrong with it. Okay, this is John DeMaio from the Museum of Yesterday back with you. I've gone ahead and troubleshot the Bendix radio that we were working on in the earlier segment, and came up to find that we had one bad resistor in it that was keeping it from working. So I replaced that resistor, and as you can see,
weaknesses of several Democratic
we now have a playing radio.
Congressional primaries. The documents talk about one candidate's history of losing primaries, and there are details on another Democrat.
So what you have here is a 69-year-old radio playing, and I'm going to go ahead. I'm going to replace a couple more capacitors in it that I think could be suspicious, just to make sure that we don't have a problem with it in the future. And I'll put it back in the cabinet, and it's going to go on display in the museum. So that completes the segment on the All-American 5 hot chassis radio repair. Again, we caution you, if you work on one of these radios, to be sure to use an isolation transformer, because you can insert the plug in the line cord plug in the wall backwards, which will make your chassis hot with 110 volts to ground. So you don't want to do that. And of course, never plug an old radio into a power source and turn it on until you're absolutely sure that you don't have any shorts or bad capacitors or anything. It's never a good idea to take a radio and plug it in just to see if it's going to work. Always start it with an isolation transformer and some means of reducing the voltage to be sure that you don't have shorted components. Otherwise, you're going to be damaging or replacing sometimes irreplaceable parts. So that's it for today. Thank you, and look forward to doing some more segments on vintage electronics. This is John DeMaio saying good day.